Hi everybody, we are here today at AMA Expo 2016 in Ontario, California. I have got the awesome opportunity to sit down with Mr. Mark Pestana. He is a research pilot with NASA, and he's joined us this year at the Expo. How are you doing today?
I'm doing great. This is terrific.
All right, you're enjoying the show?
Oh yeah, it's a great show.
Second year here, I hear.
Second year.
Awesome,
That's right, yeah.
Awesome. Well, I want to talk to you a little bit about today, as you might imagine, about how modeling is related to what you do every day at your day job. So can you start off by telling us a little bit about what you do?
Okay. I'm located at the Armstrong Flight Research Center, which is at Edwards Air Force Base in Southern California. One of the research projects we're involved with is the integration of unmanned aircraft into the National Airspace System. As you know, it's a rapidly growing field.
Yes, it is.
From small, what you would call drones, to also large aircraft like I'm flying for NASA, Predators and Global Hawks. But it all has to do with aviation safety, separation of the aircraft, and also who are the operators, the pilots and their qualifications in order to integrate safely in the national airspace.
So your background, I understand, was in manned aviation originally.
Right.
Can you talk to me a little bit about, I guess, one, what the differences are that you've experienced between manned aviation and RC aviation? Because
Okay.
you know, anyone that I've talked to in the past has said they're really vastly different in the way that they're approached. And then maybe a little bit about how you made that transition. How did you go from manned aviation into unmanned?
Okay. Well, first of all, you're absolutely correct. Very different, very challenging transition. And the best way I describe it is when I step into the ground control station, I'm actually giving up some of my senses that I'm accustomed to using when I'm flying in an aircraft. And what I mean by that is I have no sense of motion or vibrations. I can't hear an engine operating.
Sure.
And actually my vision is restricted. I do have a camera that's looking forward in the nose of the unmanned aircraft, but it's a single camera, so I don't have any three-dimensional vision, no stereo vision. So the depth perception is gone. I'm facing a screen. Now the airplane I'm flying is a version of the Predator B, and it weighs about 5 tons, fully loaded.
So just a small airplane then.
66-foot wingspan.
Wow.
So it's a huge airplane. Again, I'm restricted in the human-machine interfaces. So the controls and displays are important in how they're designed in order to give me that feedback on how well the airplane's performing. And of course, the challenges we're meeting now with integration in the national airspace is how do I see and avoid other airplanes? A traditional responsibility of a pilot in working with air traffic control. But still, it's a challenge in order to work these issues. We're doing technology advancement and experimentation on different types of instrumentation in order to accommodate the lack of ability that we normally have in manned airplanes.
Yeah, because I'm thinking if I'm in a manned aircraft and I want to see, hey, what's over to the left? I just turn my head and there it is. Or if I wonder, how's it running? Is it running right? I can listen to it, I can feel vibrations. You don't have any of that. You're flying totally from instrumentation.
That's right. So we're equipping our aircraft with some experimental hardware, some existing hardware and software, such as ADS-B, TCAS type systems, transponders, even radar. And some very clever engineers and scientists have worked out ways to integrate that information into a display that I can refer to, and I can see other air traffic, similar to a TCAS display in many other airplanes.
So for those that might not be familiar, what is a TCAS display?
Okay, the traffic collision and avoidance system, collision avoidance system.
It sounds important.
Right, so it's basically taking information off aircraft transponders and putting them in a display that a pilot can understand that shows the range and relative altitude, maybe even the speed of other airplanes that could be a conflict.
Oh, wow.
High-end models of this system also can tell the pilot what to do as far as making an avoidance maneuver.
Sure.
We're taking that a step farther as we're integrating that what to do actually automatically into the unmanned aircraft flight control system, so the airplane becomes self-avoiding. So we're showing how this can be done. It's up to the FAA to look at our flight tests and our performance and determine how to regulate that.
Sure.
So we're doing the technology and research. The FAA will look at this and determine what type of equipage, what type of procedures to develop in order to effectively integrate these aircraft safely.
That is really exciting because, I can think of myself in your position. I can't, but if I were to try to put myself in your position, seeing all of these things that I know eventually some of this is going to trickle down to consumer grade. NASA, I think, has a rich history of that innovation then benefiting everyone on the planet eventually.
I'm glad you brought that up. That's exactly it. Because in the end result, I tell people is it doesn't necessarily have to be restricted to just unmanned aircraft. All aircraft could have these eventually, and we know the history of miniaturization of electronics and computing.
Yeah.
Eventually, autopilots have made it into small airplanes. We have GPS navigation capability.
Sure.
So there's no reason that eventually any aircraft could be equipped with self-avoiding software and flight control systems that will make aviation safer for everybody.
That's really, really exciting, both from a general safety standpoint and for those of us that have kind of the geek gene.
Yeah.
The technology behind that is just mind-blowing.
And of course, a key to it is being affordable, and that comes over time. All this becomes affordable over time.
Absolutely.
Understandably, it's expensive right now.
Like
but
everything
over time,
is. Yeah.
It'll be affordable. Yeah.
So talk to me a little bit about how you made this transition from manned aircraft then into unmanned aircraft where you're working now with some of these really new and exciting technologies. What did that transition look like for you?
It was actually pretty exciting. We have a pool of pilots that are involved with a number of different research projects. Part of them are aeronautics research, advancing the technology of flight. Mm-hmm. Others actually using aircraft for earth science. So it's just like we have satellites doing it, we also have airplanes doing earth science. So I spent several years on the NASA DC-8 flying through hurricanes, sampling atmospheric pollution, using a radar to look at fault lines and rainforests. And so combining capabilities of aircraft with science objectives is what we do. So when the unmanned aircraft program came to NASA in the recent years with the Predator B and the Global Hawk, the objective was to do some research in both the aeronautics advancement and use them for earth science. And I'll give an example. Going through a hurricane is pretty brutal in an airplane.
I can imagine.
So I'm all for the capabilities of a Global Hawk that can stay aloft for 30 hours.
Oh my God.
So not only do we remove humans from danger by doing some of this research remotely, we also extend the data collection capabilities. So the scientists are very excited. The DC-8 is about a 10 to 12 hour mission, and now we can monitor a hurricane for 30 hours at a stretch. So that's tremendous to the science community. Just to answer your question about how I personally got involved, I was completing a project on the DC-8 program, and they were acquiring the Predator B aircraft. So I stepped up, volunteered to be part of that initial pilot force.
Sure.
I was trained by the manufacturer, General Atomics Aeronautical Systems in Poway, California. I was trained at their flight test facility at Gray Butte, California, which is near Edwards Air Force Base.
It's a cool experience in and of itself.
That's right. So it was about a 5-month training program, and I mentioned very different to be sitting in a trailer flying this airplane remotely.
Yeah. So aside from the see and avoid technology and the awareness technology we were speaking about earlier, any other projects that you're able to speak about maybe that you see as having a potential impact on the greater modeling or the greater aviation community?
Well, a lot of it has to do with automation and the ability of these systems to do things that pilots normally do. And we've seen automation over a century of aviation. It used to be navigation was by a map and a pilot looking at highways and railroads.
Sure.
So we know we've progressed in navigation capabilities.
Yeah.
Same way with propulsion systems. The old China Clippers that crossed the Pacific, the mechanics would crawl into the wings to put fuel in the engines on those long flights. Of course, now mechanics are all on the ground.
Yeah.
We have highly efficient engines. They run a lot longer between overhauls.
Sure.
So anything like this has benefited civil aviation all along.
Oh yeah.
And so when it comes to unmanned aircraft, it's the same thing. We have airplanes that are purpose-built for military specifications, but we're using them for earth science, and we're also advancing this aeronautics technology that will flow down to any field of aviation because of automation and computing abilities.
Sure. Well, I've got to say, it's honestly been a real honor to speak with you. Very exciting to speak face to face with someone who is doing things that are going to impact the future of everything that we do in this room and everything that's related to aviation. I can't thank you enough for taking a few minutes to come over and speak with us.
It's my pleasure. I just want to give one more plug. There's going to be a
Yeah.
special presentation every day here about a new wing shape design that we're currently testing. And it could be revolutionary for aviation all around. This new wing shape design it basically is demonstrating a huge reduction in drag due to the shape, which means fuel savings.
Oh, yeah.
It could be tremendous. So I encourage people to come on out, come to this presentation. It's at 3 o'clock in the afternoon every day here.
For any folks that can't actually make it to the show, is there any place that they can go, for example, on NASA's website to learn about the elements of the presentation?
Yeah, basically nasa.gov, and from there you can find references to aeronautics research that'll point you in the right direction.
Well, I will definitely check that out, and I will for sure see you at that presentation.